reason for the piering, we have two types of piering. Concrete piering, and we have what we call screw poles, which is what we use here. The reason for it is, in New South Wales, we always use waffle pod slabs. Now, their structure or their strength comes from the perimeter beams and their internal beams. We have to make sure they're supported and they're on the same bearing everywhere. Otherwise, if you build one half of the house on rock, the other half on sand, you haven't got much hope it's going to crack in half. So we get the same bearing. How we achieve that is by putting piers down. I find this is the quickest and cleanest way of doing it. Tomorrow when these are finished, they'll form it up and get ready to pour the slab. That's why we use them. You cannot, and this is for all people who are thinking of building, you cannot build a waffle pod slab in New South Wales without piering. So make sure when you check your contract, you've got it. Now, obviously they get done before the concrete, not after. Now you're talking about a flat site, which we have here now, and we're talking about a sloping site. Whether it be flat or sloping, we still need piering. The difference is we have to make benching so we can get the machines in to pier it. That's all it really means. We have to go down, find what they call the same KPA, which is just a bearing capacity level. How we get that is in the machine, as it turns, it has a monitor in there, and when the monitor gets to a certain amount of torque, they know they've reached the bearing capacity, they can stop. If the pier is still out of the ground, they cut it off, and then they put a cap on it, and the cap is a plate. Now the reason for the plate, you do not want your pier connected to your slab, because your slab will move. So the idea is to keep the slab on top of the plate, so if the slab wants to move, it can all move. If the load bearing is still there, doing that, you don't get cracks in your property, but please, you all need this. Make sure you got it in your contract. Look, these are the screw piles. As you can see, they're double-bladed piles, so they get better bite and they hang onto the ground better. They go in, they form the stable base. We leave them as they are. We just put the plate on top, then we pour over them and they stay there to give us the stability. The other system of using concrete, you've got to come in and drill an awful lot of 600 diameter holes, which are very big, just big enough for humans to fall in. So we don't do that. It's too slow, too messy. This way we find it's quick and simple and does the exact same job. So our engineer designs our slabs based around our geotechnical report to make sure we get into the right bearing capacity to carry our slabs. Okay, as you can see, the machine's now just coupled up to the pile and it's starting to drill it in. It's just an auger that turns around and drives it in. Once he hits what he believes is his bearing capacity, which will show up on his machine inside the cabin, he then finishes it off, completes it, and then they cut it off if they have to. If the pile is a bit short, they bring an extension arm out and drive it in that way. Now, one thing we need to look for is the fact that all the piles are different lengths. With our geotechnical engineers, we design the piles to suit the area they need to be in, so it's already determined what they think they need, so we know we've got enough length on every pile.